Hello and welcome to Mr. Tompkins EdTech and my series of walkthroughs for the AQA GCSE Mathematics past papers. This particular video is November 2018, paper 3, higher tier. Now, with the new specification being new, grade 9 to 1 past papers are like gold dust and you should not be watching this video unless you've already attempted the paper yourself under test-like conditions. If you haven't, stop the video now and go and do it first. I'm serious, go. Still watching? That's great. Why not subscribe to my channel so you can easily find it again the next time you want some help with your maths. I have plenty of A-level content too, so make sure you come back and check that out if you're carrying on with your maths next year. Please hit the like button if you found the walkthrough helpful. This really helps out my channel and it makes it much easier for others to wade through all the YouTube dross and find the good stuff. Also, before attempting the actual past papers, make sure you've gone through all the practice sets first. AQA produced 4 sets of practice papers to help students prepare for the new GCSE exams, and I would advise you to work through these before moving on to the actual past papers. Have a look at this video series which gives full walkthroughs for AQA practice sets 1 to 4. If you don't happen to have a copy yourself, you'll find a download link to the practice paper in the description below each video. Finally, feel free to ask questions below. It would be helpful if you include a question number and be as specific as possible. I really appreciate your comments and feedback and I try to respond to these as quickly as I can, especially around exam times. Okay, let's get into it. Welcome along to another AQA GCSE Mathematics past paper walkthrough. This particular paper is the November 2018 series and this is paper 3, higher tier. Question 1. A shape is translated by the vector 0, 4. In which direction does the shape move? Circle your answer. Okay, so vectors, column vectors, always given in the form of x over y, like that. So the top number, the 0, is how far it's moved in the x direction, and the bottom number, the y number, is how far it's moved in the y direction. So in this case, we're moving 4 units in the direction of y, so 4 units up and 0 units in the direction of x. So the shape is going to translate upwards. Question 2. What is 1.75 kilometers as a fraction of 700 meters? Okay, well first off, these are in different units, aren't they? So let's translate 1.75 kilometers into meters. So there are 1,000 meters in a kilometer. So 1.75 times 1,000 is 1,750. Okay, now we want to work out 1,750 meters as a fraction of 700 meters. So actually the 1750 needs to go on the top because it's a fraction of 700, so that's the one that goes on the bottom. As this is the calculator paper, I've got a calculator sitting on my desk, so I'm not going to expend any brain power in working that out. I'm just going to quickly type it in. 1750 divided by 700, that's 5 over 2. So it's that one there, isn't it? Question 3. The first 4 terms of a linear sequence are 3, 11, 19, 27. Linear sequences have a common difference. So from here to here to here should be the same number. 11 subtract 3 is 8, and that's the same as the difference between 11 and 19 and 19 to 27. So it's kind of like a +8 sequence, isn't it? Circle the expression for the nth term. Well, as it's going up in 8s, the nth term is going to have something to do with 8n. So it's clearly not that one there, n plus 8. But is it? Oh no, it's not that one there either, because it's 8 minus 5n. So it's either 8n plus 3 or 8n minus 5. Now the sequence 8n, if I had n, which gave me numbers 1, 2, 3, and 4, then 8n is going to be the numbers 8, 16, 24, 32. And I've got 3, 11, 19, 27, which is 5 less than 8n, isn't it? So the sequence I've got here is 8n minus 5. Question 4, work out the lowest common multiple of, or LCM, of 20, 30 and 40. Circle your answer. Well, I know that the common multiple of 2, 3 and 4, the lowest one is going to be 12, isn't it? So the lowest common multiple of 20, 30 and 40 is going to be 120. It's going to be that one there. Question 5. The length of a table is 110 centimeters to the nearest centimeter. Complete the error interval. Okay, so I tend to draw a line when I do these and I mark the number I've been given. Now this is to the nearest centimeter. So on my scale I'm going to go up 1 centimeter, so that would be 111, and down 1 centimeter, that would be 109. Now the numbers that round to 110 are the numbers that are going to be halfway or closer to 110. So there's all these numbers in here. These are the ones that round to 110, aren't they? And halfway between 109 and 110 is 109.5, and halfway between 110 and 111 is 110.5. So they're going to be my boundaries. Now notice really 110.5 would round up, which is why you've got this strictly less than sign in here. Question 6. A music festival has taken place each year from 2011. The table shows the number of people who attended each year. So I've got years 2011 up to 2018 and the corresponding number of people. And you can see it's generally going upwards. It's an upward trend there, isn't there? The festival organisers draw a time series graph to represent the data. The first 4 years have been plotted. Okay, so basically they're just plotting the year against the number of people, aren't they? That's what that time series is. Okay, what are the questions? Oh, complete the graph. Okay, so we've got 4 of the points down. So we've done 2011, 12, 13, 14 are all done. So we need to, next is to plot this one here, 2015 against 2023. Okay, let's have a quick look at our scale. You can see the distance between one big square like that is 500 units, and there are 5 little divisions between. So each division is going to be 100 then, isn't it? So then if I want to plot 2023, well, 2000 would be on the main line, 2100 would be the next little square up. So our point is going to be fractionally above the 2000 line, so something like that. The next point, 2016 against 2612. 2500, so one little square above 2500 is going to be 2600, which is pretty much where I'm going to plot that one. And then I've got 2017 against 3251, so I'm going to kind of plot it halfway between the 2 little squares there then. So 3012, so kind of halfway, because it's and 50, isn't it? So it should be there. And then finally 2018, 3780. So 3700, that's the second square up, but it's an 80, so it might be quite clear, quite close to the third line. Okay, so notice in the first part of the graph they've joined them together with a ruler. So I'm just going to copy that for the remainder of my diagram. Not convinced time series was on the specification, but they've shown me how it works. I'm just copying what it looks like, copying their pattern up the diagram like that. So there we go, that's all done. Okay, what now? Use the graph to estimate the number of people who will attend the festival in 2019. Okay. So we can see that there's a general upward trend of this line. It's kind of going like that, isn't it? So I would suggest that if we kind of continued this line up, then it would cross about there then, won't it? What's that value there? That would be 2019 on my X scale. And my Y scale, okay, why don't we read up and read across, show our method. Okay, so on my scale, I'm reading that as like between 4,300 and 4,400. So I'm going to estimate halfway between, so 4,350, something like that. So I'm going to estimate 4,350. Don't have to write anything here. My method is on the diagram. Question 7. We're told that k equals n squared plus 9n plus 1. Mo says k will be a prime number for all integer values of n from 1 to 9. Show that Mo is wrong. You must show that your value of k is not a prime. Okay, so let's just start off by generating some values for k. So I'm going to make a little table of values. So I've got my input values, which are n, and my output values then, which are k then, aren't they? So n can be any number between 1 and 9, like 1, 2, 3, 4, 5, 6, 7, 8, 9. Don't know if I'm going to have to do the whole table. Right, so what's the value of k then? If n is 1, then k is 1 squared plus 9 lots of 1 plus 1. Okay, so when n is 1, then k is going to be 1 squared plus 9 lots of 1 plus 1. So 1 squared is 1, 9 lots of 1 is 9, and 1 is 1. So that adds up to 11. Okay, so when n is 1, k is 11. Now, 11 is a prime, isn't it? So that one's fine. I'm going to have to keep going until I find a not prime, I think. So 2 squared plus 9 lots of 2 plus 1. So 2 squared is 4, 9 lots of 2 is 18, and 1. So 22, 23. 23 is also a prime. N is 3. What's k then? K is going to be 3 squared plus 9 lots of 3 plus 1. I don't have to do too many of these. So 9 plus 27, which is 36, plus 1, which is 37, which I think is also prime. About 4, n is 4. So k is 4 squared plus 9 lots of 4 plus 1. So 4 squared is 16. 9 lots of 4 is 36. 16 and 36. 46, 52 plus 1 is 53, which I think annoyingly might also be a prime. 5. So what have we got there then? K is equal to 5 squared plus 9 lots of 5 plus 1. So 25 and 45, 50, 70 plus 1 is 71. 71 prime. I think it might be. So what else we got? 6. K equals 6 squared plus 9 lots of 6 plus 1. 36 and 9 sixes are 54. So 54 and 36. That makes 91. 91 prime? No, 91, I'm not sure that is a prime, you know. 91. Well, it's in the 7 times table, isn't it? 70 take away from 91 is 21, and 21 is also in the 7 times table. So I think that 91 is 7 times 13. So clearly we haven't got all primes here. Did quite well up until that point, but 91 is not prime. So that's I've showed that the value of k is not prime for one of the values because I've shown a factor pair of it, so that's good. So 91 equals 7 times 3, so not prime. I think I'll just write at the front here, n equals 6, k equals 91, which is 7 times 13, so not prime. Okay, happy with that? Let's move on. Question 8. Doug owes an amount of £600. He wants to pay off this amount in 5 months. He says, each month I will pay back 20% of the amount I still owe. Show working to check if his method is correct. I don't think this is going to work, Doug. If you're just paying back 20% of what you still owe, this is a kind of never-ending sum, isn't it? Basically, it's like compound interest, isn't it? So you've got, for percentages, final, original, multiplier. The final is what we're trying to find here. The original is 600, and the multiplier, so if he's paying back 20%, then he's retaining 80% of the value then, isn't he? So you're basically times him through by 0.8 each time. So after 5 months of paying back 20%, your final then equals original times multiplier, which is 600 times 0.8, but we're doing this 5 times, aren't we? So it's to the power of 5. So after 5 months, how much will be left? 600 times 0.8 to the power of 5. That gives me £196.61. That's remaining to be paid, isn't it? So he has not cleared the £600. Okay, I think I'm just going to sign off like that. So I've shown it, haven't I? Question 9. A motor racing circuit consists of 2 parallel straight sections, each of length 0.75 kilometers, a semicircle of diameter 0.9 kilometers, and 3 equal smaller semicircles. Okay, we've got a diagram for it here. Are all the measurements on there? We're told, I think just this, the 3 equal smaller semicircles is missing, isn't it? So if it's 0.9 meters from here to here, then the diameter of each one of these smaller circles then is going to be 1/3 of that. So the distance from there to there, and similarly on the other 3, is going to be 1/3 of 0.9. It's going to be 0.3. So just as a bit of a top tip, do make sure you read through all this information at the top of the question carefully, and just check that all the information that's given written like that in the instructions are actually on the diagram. Anyway, let's move on. The length of the motor race must be greater than 305 kilometers. What is the lowest number of full laps needed at this circuit? You must show your working. Okay, so we need to know, basically we need to know the perimeter of this shape, don't we? Okay, so these bits here are no problem. That's 75, 0.75 and 0.75. We then need to work out this part of a circle here, and then we're going to have to work out this part of a circle and times it by 3, aren't we? Okay, should we do that then? So let's do the area of, so the perimeter of this one. I suppose this bit here then, this arc length, is going to be half of pi r, no, not pi r squared, pi d, isn't it? Pi times diameter, half pi times d. Here the diameter is 0.9, so that's going to be half pi 0.9. What's half pi 0.9? 0.45 pi, isn't it? I'll leave the pi in for now. And then on the other side, I've got a diameter of 0.3. So that's half of pi times the diameter of 0.3, which is 0.15 pi. But I've got 3 of those, haven't I? So then the total length of this course then, length of one lap then is going to be my 2 lots of 0.75 kilometers, my 0.45 pi for the larger semicircle, and 3 lots of 0.15 pi for my 3 smaller semicircles. Okay. Well, 3 lots of 0.15 is 0.45, and 0.45 plus 0.45 is 0.9. So actually, 2 times 0.75 is 1.5. And my 0.45 pi and my 0.45 pi gives me plus 0.9 pi. So what's that then? 1.5 plus 0.9 times pi comes out to be 4.327. I'm going to just write that down as 4.33, but when I am calculating on, I need to calculate on, so I'll just use the full calculator value. So that's what one lap is. Now if you remember, we needed to make the race greater than 305 kilometers. So if I then divide the length of one lap into 305, I should work out how many laps I need. So number of laps is going to be 305 kilometers divided by our course length of 4.33 kilometers. So let's work out how many times that goes in then. So on the calculator, 305 divided by my last answer comes out to be 70.5. So that equals 70.5. But I can't have 70.5 laps. I need to have full laps, it says in the question. So I'm going to have to round that up. So in total, that means there are 71 laps. Question 10. Solve 8 is greater than 3 minus a half of x. Now, linear inequalities you can solve the same way as you would an equation. So here I've got 3 minus a half x. Just to make that positive, I might just move it to the other side of the equation. So take that and move it over to this side. Or another way of thinking about it is adding a half x to both sides. So it would disappear on the right and reappear on the left. And at the same time, I'm going to subtract 8 from that side and move it to the other side. So I'm going to get a half x is greater than 3 subtract 8. Okay. So what does that give me? So half x is greater than 3 subtract 8 is minus 5. And then times in both sides by 2 to get rid of the half. I'm going to get x is greater than minus 10. Okay, so that's my answer. X is greater than minus 10. Question 11. Use trigonometry to work out the size of angle x. Okay. Right, so trigonometry is a right angled triangle, so it's about Socateur, isn't it? Is that how you remember it? Now, easiest thing to do is just label up the sides first. Here's my angle down here. So that means, well, that's the longest side, isn't it? So it's the hypotenuse. This 9 joins onto it, so it's the adjacent, and that makes the other side the opposite. So I have been given the adjacent and the hypotenuse, and I want x. So the ratio that includes the adjacent and the hypotenuse is that one there. Cosine. So let's write that out fully then. The cosine of an angle is equal to the adjacent divided by the hypotenuse. Okay, that's the full ratio that we need to use. So then let's sub in what we know. Cos, well, it's x in this case, not theta. Adjacent is 9 and the hypotenuse is 10. Okay, so the cos of x is 9/10. So then x is going to be the inverse cosine of 9/10. Okay, so that, reaching for the calculator, shift cos 9 divided by 10 comes out to 25.84, which we're just going to round off to one decimal place, 25.8. Question 12, Lewis wants to draw the graph y equals x cubed for values of x from -2 up to 2, and here's his graph. Okay, he's decided to join it up with straight lines, which is a bit weird. Oh, make one criticism of his graph. He's used straight lines. What's his name? Lewis. Lewis has joined his points with straight lines and not a smooth curve. There we go, done. Question 13. The probability of heads when a biased coin is thrown is 0.6. The coin is thrown 500 times. Circle the expected number of tails. Okay, so expected number of successes is going to be given by the number of trials times the relative frequency or probability of success. Okay, so in this case, I'm chucking it 500 times, and the probability of it landing on heads is 0.6. So multiplying those together, 500 times 0.6 comes out to be 300. So I would expect it to land on heads 300 times. Cheeky examiners. Circle the expected number of tails, so they've done a switcheroonie on us. So if we're expecting 300 successes, it means 300 heads, then we're going to have 200 tails there. Question 14. The mean mass of a squad of 19 hockey players is 82 kilograms. A player of mass 93 kilograms joins the squad. Work out the mean mass of the squad now. Okay, so mean is equal to sum of players, sum of mass, divided by number of players, isn't it? Okay, so in this case, we're told that the mean mass of 19 players was 82. So 82 equals the sum of their, can't write today, sum of mass divided by number of players, 19. So that means that the 19 players have a mass of 82 times 19. 82 times 19. So they weigh 1,558 kilos between them. Okay, so if the next player comes along and he weighs 93, so now I've got 20 players. Is going to be the 19 players already had plus my new player of 93. So adding on 93, that comes to 1651, and then so the mean is going to be that divided by 20 then. So new mean is going to be 1651 divided by 20, which is what? Divided by 20 comes out to be 82.55. 82.55 is my answer. Question 15. A number Question 15. A company makes two types of lampshades using fabric on wireframes. Lampshade A. Fabric is used to make a curved surface of a cylinder, and the cylinder has a radius of 8 centimeters and a height of 22 centimeters. That's both been given on the diagram. And then lampshade B, fabric is used to make the four triangular faces of a pyramid. Each triangular face has a base of 15 centimeters and a perpendicular height of 24 centimeters. So what is the question? Oh, here we go down here. So the cost of fabric is £400 per square meters. Other cost for A is £3.50 per lampshade, and other cost for B is £7.50. I assume it's for all the wire bits in between. So work out the ratio cost of one lampshade for A to the cost of one lampshade of B, and give your answer in the form of n to 1. Okay, so we need to work out, what do we need to work out? We need to work out how much material is used in both lampshades. From there we can work out the cost of the material, then we can add on the extra costs for each lampshade and come up with the total costs, and then we can make a ratio out of those two things. Okay, so quite a lot of work to do here for our 5 marks. Let's go back up to lampshade A. Okay, so what is the area of the curved surface of a cylinder equal to? Do you remember? Basically, if you kind of snipped along here and laid this flat, you would get a rectangle, wouldn't you? Now that rectangle is going to have a height of 22, because that's the height of the cylinder, and the distance along here is the same as the circumference of your circle. Now this is a circle of radius 8, so its circumference is pi times d, or 2 pi r, so that is going to be 16 pi in that direction, isn't it? 8 times 2 times pi. Okay, so we've got a rectangle which is 22 by 16 pi. So what's that then? 22 times 16 pi. Well, it's 352 pi. Just write that in for now. We need to then multiply it by the cost of the material, don't we? So what does the material cost? The fabric costs £400 per square meter. Okay, what have we got? We've got centimeters here. Okay. 352 pi square centimeters. How many square centimeters make 1 square meter? There are 100 by 100, aren't they? So 100 times 100 is 10000. So there are 10,000 cubic centimeters in 1 cubic meter. That's our conversion rate. Okay, so how many cubic meters do we have then? So then the cost of this is going to be our 352 pi, which is our area, but that's in squared centimeters. So we need to divide that by 10,000 to get square meters, and then we need to times it by the cost of 1 square meter, which we said was £400. Wow, that's expensive cloth. £400 for 1 square meter of this stuff. I don't know what it's made out of. Anyway, let's do the calculation. So 352 pi divided by 10,000, and then times by 400. That means the cost of this material is going to be £44 and £44.23. Okay, that's the cost of the cylinder lampshade. Let's move on to lampshade B. So fabric is used to make 4 triangular faces of the pyramid. So we need to work out the area of one triangle and then multiply it by 4. I assume they're all the same size, are they? Okay, let's do that then. So the area of this shape then, it's going to be a half base times height, which is a half times 15 times 24, which is half times 15 times 24. That's 180. Again, that's going to be squared centimeters, but I've got 4 of them, haven't I? So then the total cost of this lampshade is going to be my 4 triangles, 4 lots of 180, divided by 10,000, because that is in squared centimeters and we want square meters, times by the cost of 1 square meter, which was the outrageous price of £400. So how much does this one cost then? 4 times 180 divided by 10,000 times by 400. So the material here costs £28 and 8 pence. 80 pence, sorry. Okay, so a bit cheaper than that one, but then remember it's got more wiry bits for this one. So let's find what the final price was then. So coming down here then, other costs, so the total cost then for A is going to be my £44.23. £44.23 plus my other costs of £3 and 50 pence, which comes to £47.73. And then for B then, the total cost, total cost of B then is going to be £28.80. £28.80 plus our extra costs of £7.50, giving us a total cost of 28.8 plus £7.50 comes to £36.30. So then the ratio of cost A to cost B then is going to be our £47.73 to our £36.30. Now we're told that we need to give the answer in the form n to 1. So we need to make that second number 1, and we do that by dividing by £36.30. Do the same on this side. That will give me 1 on the right, and then on the left I'm going to get 47.73 divided by 36.3, which comes out to 1.31487, and there's a recurring thing in there somewhere. So I'm going to write that down to 3 significant figures, I think. So I'm going to just write that down as 1.31. Doesn't tell me how to write it down, so I'm just going to assume it's going to be to 1.31, something like that. Question 16. In a running club, there are 50 females and 80 males. If a female is chosen at random, the probability that she has blue eyes is 0.38. If a male is chosen at random, the probability that he has blue eyes is 0.6. One person is chosen at random. Show that the probability the person that has blue eyes is more than 0.5. Okay, I'm going to write this down as a tree diagram. First off, I'm going to have a branch for male and female, for my 50 and my 80 males and females. So that's the female branch, and that is the male branch. So if I'm picking one runner at random, the probability I'm going to pick female is going to be my 50 females divided by my total number of people to pick from, which is 50 plus 80, isn't there? 50 males 50 females, 80 males, giving you a total of 130 people to pick from. So there's a 50 in 130 chance of picking a female, and there is an 80 in 130 chance in picking a male. Okay, now let's assume you picked a female. If I picked a female, the probability that she has blue eyes is 0.38. So blue, that branch is 0.38, and then the other branch then is going to be not blue, which would be 1 minus 0.38, which would be 0.62. And then the male branch, if chosen at random, probability that he has blue eyes is 0.6. So for that one, blue is 0.6, and not blue then is going to be 0.4. So that's my tree diagram. So the probability that the person has blue eyes is either that they are female and blue-eyed, or they are male and blue-eyed. So we need to add those two roots. Okay, so probability blue eyes is going to be the probability of female blue plus the probability of male blue. Okay, which is going to be 50 out of 130 times by 0.38. Mixing my units, but it doesn't really matter. And or means add, so that's 80 over 130 times 0.6. So what's that then? Reach for the calculator. So first 50 over 130 times 0.38 plus 80 over 130 times by 0.6. Now that comes out to be 67 over 130. I'm just going to leave it like that. It's a fraction. It's nice and neat. Question 17. We're told that w equals 3 over 5 root x. Circle the expression for w squared. Okay, well, w squared is going to be our 3 over 5 root x all squared. Now, when we've got an index on the outside of a bracket like this and a product or quotient inside, then every part is going to be squared. So I'm going to square the 3, I'm going to square the 5, I'm going to square the root x. So that's going to give me 3 squared is 9 divided by 5 squared, which is 25, times root x squared, and root x squared is just x. So I'm going to get a 9 over 25x. It's that one. Question 18. Here is some information about the ages of people at a concert. You can see I've got a grouped frequency table there. So I've got groups 10 to 15, 15 to 25, 25 to 40, 40 to 70. Just noticing that the gaps between these are not consistent. So the first gap is 5, the second gap is 10, the third gap is 15, and the last gap is 30. So we've got different width groups here. I've got a feeling a histogram is going to come on. Yep, here we go. Draw a histogram to represent the information. Okay, so with histogram, we are going to be using the width of the bar, and we're going to work out frequency density. I'm just going to write that down as FD. I'm just going to use the structure they've given me here for the table. I'm just going to make it a bit bigger, add another couple of columns on the end. Okay, so I've got a column now for width and one for frequency density. So the first category, 10 to 15, has a width of 5, class width of 5. Second one, 25 subtract 15, has a class width of 10. The third one, 40 take away 25 is 15, and finally that one's 30, isn't it? Okay, now frequency density is frequency divided by class width. So my frequency density for the first group is going to be 8 divided by 5. So 8 divided by 5 has a frequency density of 1.6. My next group, 24 divided by 10, I can do that in my head, that's just 2.4. Third one, 30 divided by 15, I can do that as well, it's 2. And finally 39 divided by 30. Might reach for a calculator for that one. 39 divided by 30 is 1.3. Okay, they're going to be the heights of my bar. So because histogram, you are plotting your values against frequency density. It's even given here, look. Okay, so now I've worked out all my frequency densities. I'm going to draw the bars below. So my first bar is going to be a width of 5 from 10 to 15 and a height of 1.6. Okay, I'm going to cheat, use auto shape. So 10 to 15 and a height of 1.6. So a square. Oh no, I'm not going to use that pen though. From 10 to 15 and a height of 1.6. Okay. The next one, 15 to 25 with a height of 2.4. Okay, there we go. So just remember, with a histogram, it's the area of bar that is proportional to the frequency and not its height. So, job done. Question 90. The length of a roll of ribbon is 30 meters, correct to the nearest half a meter. A piece of length of 5.8 meters, correct to the nearest 10 centimeters, is cut from the roll. Work out the maximum possible length of ribbon left on the roll. Okay, so for the ribbon, first off, I'm going to do the same as what I did earlier. I'm going to draw a number line. I am going to mark on what I've been given. Now it's correct to the nearest half meter. So if I go half a meter up from there, it'd be 30.5 is the next number on my scale, and half a meter down from there is 29.5. So the numbers that round to 30 are the ones that are halfway between those or nearer. So all these numbers in here round to 30. Now halfway between 29.5 and 30, that's going to be 29.75, and halfway between 30 and 30.5 is going to be 30.25. Okay, so my upper bound and lower bound for the ribbon is 29.75 and 30.25. Okay, let's have a think of the offcut now, the bit that we're cutting off. We're told that is 5.8 meters, correct to the nearest 10 centimeters. So again, let's mark our scale with the number we've been given. It's 5.8. Now it's correct to the nearest 10 centimeters. 5.8 meters is 580 centimeters, isn't it? So 10 centimeters more than that is 590 centimeters. In other words, 5.9 is the next one up on my scale, and the one below is 5.7. So the numbers that are halfway between those or closer are going to round to 5.8. So this is my area that rounds to 5.8. So halfway between 5.7 and 5.8, the rounding point or the limit of accuracy there is 5.75, and the upper bound is 5.85. Okay. Okay, so what we're doing, we're taking our ribbon and we're cutting the offset off, and we want to maximize the bit of ribbon that is left. So our maximum length we're going to get is going to be our biggest bit of ribbon to start with, subtract our smallest possible offcut. So it's that one there then, isn't it? So it's going to be our 30.25, our upper bound for the length of the ribbon, subtract the lower bound of the offcut. and that leaves us with 30.25, subtract 5.75, 24.5 meters. Question 20. Curve P has equation y equals 2 lots of x minus 1 all squared minus 5. So that's given in complete square form, isn't it? It's a quadratic in complete square form. Curve Q is a reflection in the y-axis of that curve. Work out the equation of curve Q. So when we've got some function in x, y is equal to f of x, and we then reflect it in the y-axis, that goes to y is equal to f of minus x. Okay, you need to remember your 6 different types of possible graph transformations they're going to give you, and what it does with the algebraic versions of their equations. So that's what you get when you reflect something in the y-axis. Y equals f of x goes to y equals f of minus x. Okay, so basically what we need to do is we need to go through our equation above and replace our x with minus x. So we're going to rewrite the equation. So curve Q then is going to be that same equation but with the x replaced with minus x. So all we've got to do now is tidy that up a little bit. So minus x minus 1 all squared. It's going to be minus x minus 1 times minus x minus 1 minus 5. Okay, so that's going to be 2 lots of minus x times minus x is positive x squared. Minus x times minus 1 is plus x. Minus 1 times minus x is plus x, and minus 1 times minus 1 is 1. So it seems to have made everything positive. And then, so I've got inside my brackets 2 lots of x squared plus 2x plus 1. Okay, then removing the brackets, I'm going to get 2 lots of x squared plus 4x plus 2 subtract 5, which comes out to be 2x squared plus 4x minus 3. That's my final answer then. Question 21. Priya and Joe travel the same 16.8 kilometer route. Priya starts at 9 AM and walks at a constant speed of 6 kilometers per hour. Joe starts at 9:30 AM and runs at a constant speed. Joe overtakes Priya at 10:20 AM. At what time does Joe finish the route? I think I'm just going to sketch this for myself as a quick distance time graph, so just get a bit of a better understanding of what's going on. So if I've got time and distance, then I've got Priya starting at 9. So let's call the origin 9 AM. And so she's walking at a constant speed of 6 kilometers per hour, isn't she? So she's going to be moving at a distance like that. And then we've got Joe, who's going to start his journey a little bit later at 9:30. And he's going to be running at a constant speed. So he's going to be going at a faster pace than Priya. And so at some point he's going to overtake her. I suppose, what time does it finish? I know. So we're not told his constant speed. We just know when he overtakes her. So we know that time there is 10:20. Okay. So what we need to do then from that is work out how fast he's going, and therefore how long is it going to take him to finish the route. So looking at this diagram, I'm thinking, well, what I want to do is I want to work out that value there then, how far they'd both travelled when Joe overtakes Priya. Okay, now I've got the time that happened, and that is at 10:20. So, and I know that how fast Priya is walking, so I should be able to work out that distance, and then from that I can perhaps work out the speed that Joe is travelling, and that will be able to answer the question. Okay, so what is that distance d at time 10:20? So at 10:20, then the distance travelled is what I want to find. The speed is 6 kilometers per hour, and the time is 9 till 10:20, so that's 1 hour and 20 minutes, or 1 1/3 of an hour. Okay, so using a DST triangle, distance, speed, time, I know that distance travelled is speed times time. So distance is going to be speed times time, which in this case is a speed of 6 kilometers an hour times time of 1 1/3 of an hour. So that's a 6 1/3 of a 6, which is 8, isn't it? So that must have been 8 kilometers. So that D there, that's 8 kilometers. That is the point where Joe overtakes Priya at the 8 kilometer mark. Okay, so let's work out how fast Joe is running then. So for Joe, so this is Priya, isn't it, what I did here? This is Priya's journey. So now we move on to Joe. He left at 9:30, and so by the time he got to 10:20, the distance we know was 8 kilometers. It's the same as Priya travelled. The speed is what we're trying to find, and the time taken is 9:30 to 10:20, so that's half an hour and 1/3 of an hour. 50 minutes, or 5/6 of an hour, isn't it? I'm going to say that's 50 minutes or 5/6 of an hour. So that's kilometers, and that is in hours. So then Joe's speed then, again using the DST triangle, DST, cover up the thing you want to find. So speed equals distance travelled divided by time taken. So he's going to do is 8 kilometers in 5/6 of an hour. So 8 divided by 5/6. 8 divided by 5/6 comes out to be 9.6. So he's running at 9.6 kilometers per hour. Okay, so what do we now need to do? At what time does Joe finish the route? Okay, so coming back to Priya, how long is the route altogether? Oh no, it's 16.8 kilometers, we're told in the question. So we're told that the route is 16.8 kilometers. We know the speed he's running, so now we can work out the time it takes him to do that second, or the whole journey then. So for the whole journey, then we've got distance travelled is 16.8. Our speed then is, we've just worked out to be 9.6, so then the time is what we want to now find then, isn't it? So again, we're using our triangle, cover up the T, time equals distance over speed. So that is equal to 16.8 divided by 9.6, which is it's coming out to be 1.75 to me. 1.75, or 1 3/4 of an hour then, isn't it? So 1 3/4 is 1 hour and 45 minutes. 1 hour 45 mins. At what time does he finish the route? Okay, I haven't done that yet. So 1 hour and 45 minutes as he started the journey at 9:30. We're going to add on from there then, aren't we? So 1 hour and 45 minutes after 9:30. An hour after 9:30 is 10:30, and 45 minutes after that is 11:15 a.m. That's the time he's going to get in. Okay, job done. Question 22. An approximate solution to an equation is found using the iterative formula xn plus 1 is equal to x to the n all cubed minus 2 all divided by 10, where x1 is equal to minus 1. Part A says work out the values of x2 and x3. Okay, well, this is our iterative formula here, xn plus 1, and what we do is we sub in our last value into the formula to get our next value. So if x1 is equal to minus 1, like it says in the question, then x2 then is going to be my x1 value, which is minus 1, all cubed, subtract 2, and then divided by 10, which is what? It is -1 cubed is -1, subtract 2 is -3, divided by 10 is -0.3 then, isn't it? Right, now x3 then I'm going to get by taking minus 0.3 and cubing it and then subtracting 2 and divide by 10. Now, I'm not going to be able to do that in my head. And I think what I'm going to do is I'm going to show you a trick with the calculator with these sorts of things. Okay, so what I'm going to do is I'm going to start with my first value, x1 equals minus 1. I'm just going to type that into the calculator. So -1, and then I'm going to press the equal button. What that will do is it will store -1 as the last calculated value. Okay, so now what I'm going to do is then set up a calculation involving that answer so I can keep feeding it back in on itself. So I'm going to type open bracket answer cubed minus 2 close bracket divided by 10. Now what that will do is will take my last calculated value of minus 1 and will feed it and it will appear there where the answer is. So minus 1 cubed take away 2 divided by 10. That gives me my x2 value. You can see minus 0.3. But the clever thing is, if I then press the equal button again, now that answer then will get fed into that same calculation and it will give me my next value, the x3 value. So if I press equals again, you can see that comes out to be minus 0.2027. So that is equal to, oops, change pen, minus 0.2027. So that was my x2 and my x3 value, minus 0.3 and minus 0.2027. And the next part says, look, work out the solution to 5 decimal places. So I just need to keep generating more and more values, and it should start homing in on the true answer as we move on. So that's x3 was that one. So let's press the equal button again on the calculator, and that will feed my x3 value back into the iterative formula, and it will give me my x4 value. So x4 should be that one there. So x4 equals negative 20083. 20083. Now it wants me to show it's settling down on 5 decimal places, so I'm going to write down the first 6 for now, and then let's generate x5. So press the equal button again. You can see that gives me minus 0.2008110. Okay, so you can see it's kind of settled down up to about here so far, to 4 decimal places. Let's do another one. Now I'm getting x6, which is minus 0.2008 Okay, so again, it's not quite settled yet, is it? It's still only settled as far as here. The last one is, the last 2 digits are still moving around. So let's try one more. Okay, seems to have kind of settled now all the way. So now I've got x7. I've got minus 0.200809 still. Okay, and if I keep pressing the equals sign button after that, you can see it doesn't change after that. It keeps coming up with the same answer. So you can see the number pattern is kind of settled down all the way down to here, which is to 6 decimal places. We only need to quote this to 5. So really we should round off at this point. And because it's a 9, I'm going to round up. So my final answer I'm going to give is minus 0.20081. Question 23. The diagram shows the side view of a step ladder with a horizontal strut of length 48 centimeters. The strut is 1/3 of the way up the ladder. The symmetrical cross section of the ladder shows 2 similar triangles. Okay, and we need to work out h, the height of this ladder. Interesting question. What do we know? Is all the information that's in the question already on the diagram? So it's got a horizontal strut, 48. The strut is 1/3 of the way up the ladder. Now that bit is missing. I'm going to kind of sketch that in, I think. So just going to add a line from there to there. So then the distance from the ground to the ladder there is 1/3. And then this is 2/3, isn't it? So it's 1/3 to 2/3. So that kind of tells us the ratio then of these 2 similar triangles. Then you've got 2 similar triangles here, and if there are 1/3 and 2/3, then they're in the ratio of 2 to 3. Then so for every 2 units you've got in the first one, you've got 3 in the second one there. Okay, so we want to basically work out what the length of that line is. Now, I suppose we could add a right angle there if we're dropping it straight down from the top. So then the distance from there to there is half the baseline. Now, if the height of this, if it's in the ratio of 2 to 3, and this distance is 48, if we use that, we can then use that to work out this distance here, the length of this baseline. We can say that. So I'm going to say that the base of my larger triangle is going to be 48 centimeters, which is the kind of the baseline of the smaller of the 2 triangles. And then I'm going to divide that by 2 and times it by 3. So it's 3 over 2 lots of that then, isn't it? Divide by 2 times by 3. So 48 divided by 2 is 24, times by 3 is 72. So that's going to be 72 centimeters. So then I wanted to halve that, didn't I? So half of 72 is 36. So this distance here must be 36. Okay, so that's 36. And I've got the hypotenuse of the long triangle. So now I can use Pythagoras theorem to work out the height. I can say that h squared, the height of my pyramid, is going to be 141 squared subtract 36 squared. And that's using Pythagoras, isn't it? So what is 141 squared minus 36 squared? 141 squared minus 36 squared comes out to be 18,585. So then h is going to be the square root of that then, isn't it? So root answer, that's 136.3. Does that look right in my diagram? 136, it's one of the shorter sides, so it's certainly a little bit less than 141. That looks about right to me. 136.3. Question 24. We've been reminded of the volume of a sphere and volume of a cone formula. And then we're told a sphere has radius 2x centimeters and a cone has radius 3x centimeters with a perpendicular height of h. The sphere and the cone have the same volume. Work out the radius of cone to the perpendicular height of the cone. Give your answer in the form a to b, where a and b are integers. Okay, what a fun question. So, where to start? Should we start with the sphere? So, for the sphere then, we know that the volume is 4/3 pi r cubed, and for the sphere here we've been given a radius of 2x. So we're going to sub that in. So that is going to be equal to 4/3 of pi times 2x all cubed. What's that equal to then? When you cube something like this, don't forget to cube both parts. So that's going to be 8x cubed when I cube it. So that's going to be 4 pi times 8x cubed over 3. So then 4 times 8 is what? That's 32, isn't it? 32 pi x to the power of 3 over 3. I think that's about as far as I can get with that one for now. Let's just hang there for a bit. Let's switch attention to the cone. Now the cone has a radius of 3x, and the cone formula is 1/3 of pi r squared h, isn't it? So in this case, our r, we're told, is 3x, and it has a height of h, so we're basically leaving h in for now. Okay, but replacing the r with 3x, that's going to be 1/3 of pi times 3x all squared times h. So let's just tidy that one up as well. Don't forget to square both of these. So that's going to be 1/3 of pi times 9x squared h. I can divide that 3 into the 9 and give me 3 there. So it tidies up to 3 pi x squared h. Okay? So I've got an expression for the sphere in terms of x, and I've got an expression for the cone in terms of x and h. We need to work out the radius of the cone compared to the perpendicular height of the cone. Well, that's interesting. So we need to have a formula. We need to find out the ratio of, well, we need to find x and h a bit more, yeah? What are we going to do here? I suppose we can equate it and come up with a formula for x and h, can't we? Let's do that. Let's stick these two things together. We're told in the question that the sphere and the cone have the same volume. So we can take our two equations and we can equate them to each other. So these have got the same volume. So I can say that 32 pi x cubed over 3 is equal to 3 pi x squared h. Okay, can I cancel some things here? I think I'm going to times both sides by 3 to get rid of that annoying 3 there. and I'm going to divide by pi, so they'll disappear. I'm going to divide by x squared, so that will disappear. And I'm going to be left with 32x is equal to 9h. Okay. So I'm going to rewrite that as, I think I need to be careful here because I need to do a radius of the cone to the perpendicular height of the cone, and the radius is 3x. Anyway, let's just get a relationship between x and h first, and we can have a think about that. So I'm going to say then that x, let's just rearrange that. So x over h is equal to, just by cross multiplying, I'm just going to move that down there, and I'm going to move that down there. So I'm going to get x over h is equal to 9 over 32. Now, normally at this point then, I would just say then the ratio of x to h is 9 to 32, but that's not quite what the ratio is that we've been asked to find here. If you remember, the question asked for the radius of the ratio of the radius of the cone to the perpendicular height of the cone. So the radius of the cone is actually 3x and not just x, and the height of the cone is h. So I need to have a ratio of 3x to h, not the ratio of x to h. So I'm just going to multiply both sides by 3 first before I then equate them. So that's going to give me 3x over h is equal to 27 over 32. So therefore the ratio of 3x to h is equal to 27 to 32. Do I need to give it any form? No, just need to be as integers. So they're both as integers, aren't they? So the ratio of 3x to h is 27 to 32. So that's my final answer then, 27 to 32. A bit tricky, that one. Question 25. ABCD is a quadrilateral. And I've got a picture of it there, and I can see the coordinates of each of the vertices. And it says the quadrilateral is reflected in the line x equals 4. Which vertices are invariant? Now, invariant means that when the transformation happens, those particular vertices don't move. Okay, so where is the line x is equal to 4? Now, you should remember that a line with the equation x is equal to something is a vertical line through that number. So it's going to be this line here, isn't it? Passing through 4. You notice the x coordinate of c and d are both 4, so that line must pass through there. So obviously my point D is going to be reflected over here to give me D dash, and my point A is going to be reflected over here to give me A dash. But my points C and B lie on the mirror line, so they're not going to be reflected. Well, they are going to be reflected, but they're going to be reflected onto themselves. So the shape's going to end up looking like that, and the points B and C are the ones that don't move. Okay, so B and C are my invariant points, B and C. Question 26, we're given a function in x as 2x plus 3 over x minus 4, and we need to work out f to the minus 1 of x, or the inverse function. Now, the technique for doing this is just start off by replacing f of x with y, so make it y is equal to 2x plus 3 over x minus 4, and then try to change the subject of the formula, so you make y the subject rather than x. That's the first step anyway. So let's start off by cross multiplying this denominator over to the other side. So I get y x minus 4 is equal to 2x plus 3. Removing the brackets, I'm going to get xy minus 4y is equal to 2x plus 3. Okay, what am I trying to do? I'm trying to get x, make x the subject of this formula. So then let's move that to this side, move this to this side. I'm going to get xy minus 2x is equal to 4y plus 3. Next thing I'm going to do is factorize the x out of these two terms. So I'm going to get x y minus 2. The reason for that is I need to have one instance of the x. That's why I'm bringing them to both sides and factorizing. I need to try and just get 1x because I want to make x a subject. Okay, and now what I can do is then just cross multiply this back down there. So I'm going to get x is equal to 4y plus 3 all over y minus 2. Okay, so now I've got x in terms of y. I can just say that f to the minus 1 of x is equal to, I'm going to write the same expression down, but I'm going to switch back the y's back into x's. So I'm going to say that 4x plus 3 over x minus 2 is my inverse function. So from the top then, I replaced f of x with y. So I had an equation in y. I then changed the subject from y to x, and then I replaced my y's back again with x's, and then that is your inverse function. Advertisement break. Hopefully you are able to use this past paper to identify any topics that you still need to focus on for your exams. It's best if you do some focused revision around these topics between past papers, and this series of videos will help you do just that. They are based on the AQA topic tests, including key topics like trigonometry, surds, indices, and a whole lot more. Click on the card above to go to the playlist. I'm adding to this collection all of the time, so if the topic is you're looking for is not yet covered, it soon will be. So subscribe below to make sure you don't miss out on any of these uploads. Right, back to the maths. Question 27. The line y is equal to 3x plus p and the circle x squared plus y squared equals 53 intersect at the points A and B. P is a positive integer. Show that the coordinates of the points A and B satisfy 10x squared plus 6px plus p squared minus 53 is equal to 0. Okay, so this is a geometry question, but there's no diagram. Now let's just quickly sketch. I can show you what's going on. So if I've got a pair of axes, x and y, then you should recognize that this is the equation of a circle. In fact, it tells you here. So x squared plus y squared equals 53. Now the root of 53 is going to be the radius of this shape. Okay, the root of 53 is a little bit more than 7, not quite 8. Okay, so imagine a circle with radius between about 7 and 8. Okay, centered on the origin. Okay, like that. And then I've got a line y is equal to 3x plus p. So 3x is the gradient, so it's quite a steep line, and p is the intercept. Now I don't know, I was told it's positive, so it must be a line that looks a bit like that, so it passes above 0 on the y-axis. So our two coordinates then we're looking for are like this one down here, that's going to be our A or our B perhaps, and then this one up here is going to be our B or our A perhaps. Okay, so that's what I'm trying to find. I'm trying to find that the coordinates then satisfy that equation. Okay, now the way I'm going to do that is I'm going to try and solve these simultaneously. Okay, so I've got the equation y is equal to 3x plus p, which I'm going to call equation 1. And I've got x squared plus y squared is equal to 53, which I'm going to call equation 2. Now, when you've got simultaneous equations like this, where they're not both linear equations, you can't just eliminate them like you can with simpler cases. If they were both linear equations, I could look to eliminate x or y and solve that way, but it isn't going to work here. The only way you can solve these is by a method called substitution. So I'm going to take the easier looking equation, y equals 3x plus p, and I'm going to substitute it into my kind of more complicated looking equation, x squared plus y squared is equal to 53. In other words, I'm going to take this y here and I'm going to replace it with what y is equal to in the other equation. I'm going to replace it with that. Okay, so what I've highlighted in yellow in the first equation is going to go into that second equation there. So I'm going to get x squared plus y squared, in other words 3x plus p all squared, is equal to 53. Okay, right, now what? Well, I've got a pair of brackets with a square. Now you can either write those out as double brackets and multiply them out, or you can remember the identity for square in a bracket, which is what I tend to do. I kind of just remember that a plus b all squared is equal to a squared plus 2ab plus b squared. Okay, this is what we call an identity, and you can just use it to do quick expansions of these sorts of things. So I've got x squared plus, so basically it's the first term squared, 3x squared, which is 9x all squared, plus two lots of the two things multiplied together, so that's going to be 6xp, plus the last term all squared plus p squared. If you don't like doing it like that, you can just write it out as two brackets and multiply it out if you prefer. Okay, so I'm getting that. Well, I think we're almost there anyway, aren't we? If I have a look. So I've got x squared plus 9x squared, so they collect together into 10x squared. And I've got 6xp, and I've got p squared. And then I suppose if I then take this 53 over the equal sign, it's going to change signs to minus 53 is equal to 0. Okay, so that's what I needed to do, didn't it? So what I've got here now then is the same as what's here, so I have shown it. Okay, so I've done that. Okay, I bet I have to go and do something more with that though. What does part B say? Now in part B we're told that the coordinates of A are 2, 7, and we need to work out the coordinates of B. And we must show our working. Okay, so you remember that we've been given two equations, and the first one was y is equal to 3x plus p. Okay, now we've got a pair of values that go together, our coordinate of A. We can say that when x equals 2, y must be equal to 7, which gives us a means to evaluate what p is. So sub in x and y into this equation, I'm going to get 7 is equal to 3 lots of 2 plus p. In other words, 7 is equal to 6 plus p, so that makes p equal to 1. Okay, so now we know what p is. We can sub it into that ridiculously long quadratic we had earlier. So what was it again? Right. So I've got 10x squared plus 6px plus p squared minus 53 is equal to 0. See how much of that I can remember. 10x squared plus, I've forgotten it already, 6px plus p squared, 6px plus p squared minus 53, wasn't it? Minus 53 is equal to 0. Minus 53 is equal to 0. So now we know that p is equal to 1. So, but p is equal to 1. So that means I've got 10x squared plus 6x plus 1 minus 53 is equal to 0. So then just collecting the constant together at the end, that's minus 52 is equal to 0. Okay. So I've got a quadratic in x. Can I factorize it? Well, I know what one of the factors is. One of the factors is 2, because it's that up there. So does the other one work? Well, we can make it look a little bit easier. If we divide everything by 2, we'll just reduce the constants down a little bit. I'll get 5x squared plus 3x minus 26 is equal to 0. And then because I know that x equals 2 up there, it might factorize into some brackets where I've got a 2 here then, isn't it? So an x minus 2 like that. And then what would I have to have here then to make that work? I'd have to have a 13, wouldn't I? So if I had a 13 there and a 5x, does that work? So 13 take away 10 would give me the 3x. Yeah, that seems to work. So 5x plus 13, x minus 2 is equal to 0. Okay, so we already knew that one of the solutions was x equal to 2. That's our first coordinate that we had earlier, but now we know that also that x could be minus 13 fifths. So that's our second solution for x. Okay, so if x is minus 13 over 5, we can use our more simple equation, this one up here, oops, didn't mean to cross it out, this one up here to work it out, can't we? So when x equals minus 13 over 5, then y is going to be 3 lots of minus 13 over 5 plus 1 then, isn't it? What's that? So y equals minus 39 over 5 plus 1. So 1 is 5 fifths. So add that on to minus 39 fifths makes minus 34 fifths. So I'm thinking that our other coordinate is going to be minus 13 over 5 and minus 34 over 5. Not particularly nice coordinate, but there you go. Just wanted to take a few seconds out to talk about my Patreon page, which you can find at patreon.com/Mr. Tompkins EdTech. On here you can gain access to exclusive content, including early access to my past paper walkthroughs. So if you like my content, definitely worth checking that out. Also, if you become a Pythagorean patron, you get a special shout out in every video. So check it out. Back to the maths. Question 28. Here is a sketch of a quadratic curve. The turning point is 3 minus 2. Circle the correct statement about the gradient of the curve. Is it positive, 0, negative, or could it be any value? Okay. So when is x less than less than 3? Well, you'll see the coordinate we've been given is 3 minus 2. So the x value there is 3. So if I read up to the axes at that point there would be the point 3. So we're talking about the bit of the curve that is less than that. So it's this part of the curve here we're talking about, down to that point there. Okay? So for all of that section of the graph where it's less than 3, can you see it's always sloping downwards in that pace, in that place. Once you get to 3, it becomes 0. And then to the right of 3, greater than 3, it starts sloping up again. But for the bit we're talking about, the gradient is negative. It's always sloping downwards, so it's that one there. Oh, that was a little bit dramatic. Let's try a different pen. That one there. And with that, we are done. Excellent job. So that's all. We've reached the end of the paper. How did you do? Let me know in the comments below, along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.